Now that we have seen generally how the different Kawasaki ignition systems work in Ignition System Part 1, let's look at some specific installations in different Kawasaki products. Kawasaki watercraft all use magneto-CDI systems. The whole system is sealed so water cannot affect it. The magneto flywheel and stator are inside this cover on the front of the engine. The pulsar coil and the exciter coil for the capacitor are both inside the flywheel. The spark plug wires and caps are fully sealed. And the igniter and other parts are safe inside the electric case. In this case, the igniter unit and the high tension coil are combined into one unit. These are the spark plug leads, and these wires are from the magneto. Connecting a voltmeter across the leads from the pulsar coil will show us its output as the engine turns. Some jet ski models do not have a separate pulsar coil. They use half of the sine wave output of the exciter coil to charge the capacitor and the other half as a timing signal. The JS550C model has an analog advancer system which is used to control peak engine speed. Besides advancing the timing as engine speed increases, this system cuts the spark at high RPM to protect the engine from running too fast. A separate controller unit in the electric case performs the over-rev limiter function. The rev limiter in the JH750 is built into the digital advancer circuit in the ignition system. It is accurate to about 100 RPM. But it can do even more. This system has a temperature sensor in the coolant bypass line. If the cooling system clogs, limiting coolant flow to the engine so that it begins to overheat, the ignition system slows the engine to 3,500 RPM. This protects the engine from overheating damage while allowing the rider to get back to shore. At the same time, a light on the dash warns the rider of the overheating problem. Magneto-CDI systems are also used on most Kawasaki two-stroke motorcycles. Two-stroke engines must have oil in their fuel, which can easily foul the spark plug. Magneto-CDI systems have the short rise time and powerful spark needed to fire spark plugs under these conditions. These models may have a flywheel or a rotor in the magneto. The pickup coil is easy to see on this KX125J. But on this model with a rotor, a pulsar coil is mounted with the exciter coil used for charging the capacitor. Some CDI systems have two exciter coils, one densely wound coil to produce lots of output at low engine speeds, and another more loosely wound to provide output at high engine speeds. The low-speed coil does not charge quickly enough at high speed to supply the system, and the high-speed coil cannot produce enough at low speed. Together, they keep the system supplied at all engine speeds. Because they don't like high temperatures, the ignition coil and igniter unit are mounted away from the heat of the engine. Kawasaki's most popular motocross bikes have digital advancer type magneto-CDI systems. Starting with the 1990 models, the KX80, 125, and 250 have used this system. Its accuracy and versatility make the digital system ideal on the racetrack. In most markets, the KDX models get an analog version of the magneto CDI system. Magneto CDI with an analog advancer circuit is also used on the dual-purpose four-stroke models. This system is used because it is lightweight and the engine can be kick-started even if the battery is discharged. A heavy flywheel helps the engine run smoothly at low speeds while generating the power to charge the capacitor. This projection triggers the pickup coil mounted outside the flywheel. The stator supplies power to both the battery and to the capacitor in this type of CDI system. The igniter unit under the seat is separate from the high-tension coil, which is mounted under the fuel tank. Kawasaki's all-terrain vehicles use both CDI and TCBI systems. The TCBI systems will be covered later in the street motorcycle section. ATVs use CDI systems for the same reasons as off-road and dual-purpose motorcycles. The systems are light and reliable. And the engine can be easily started without the battery. In this Kawasaki ATV, the stator is mounted on the magneto cover, and the open side of the flywheel faces away from the engine. The high-tension coil is mounted just above the front of the cylinder head to be close to the spark plug. The igniter unit is hidden behind the bodywork in front of the steering stem or under the seat, where it is easy to get to. A different CDI system appears on some Kawasaki ATVs. It's battery-powered. The flywheel and stator on the KLF 400 are purely for charging the battery, which in turn powers the CDI system. The pickup coil is the same as in the magneto CDI systems. Direct current power from the battery is changed to alternating current, run through a transformer to raise the voltage, then rectified back to direct current and used to charge the capacitor. The rest of the system works the same as the magneto CDI. Though this system is more complex than a magneto-powered CDI, it has the advantage of being able to deliver full voltage to the spark plug at very low engine speeds. This is valuable for agricultural work such as spraying, where the tow vehicle must run powerfully at very low speeds for long periods. Kawasaki street motorcycles typically use a transistor-controlled breakerless ignition system, TCBI. The significant advantage of this battery coil system for street use is its relatively long spark duration. Engines that must meet exhaust emissions limits are generally run quite lean. The longer spark duration of the battery coil ignition system increases the probability that a combustible fuel-air mixture will be close enough to the spark plug to be ignited. Also, because it is transistor-controlled and breakerless, the TCBI system is very reliable and does not need much maintenance. TCBI systems may be equipped with analog or digital advancers. Most Kawasaki street motorcycles now have digital systems because they are more accurate, allowing better performance while still meeting exhaust emission limits. In these systems, the pickup coils are mounted close to the crankshaft, and projections on a rotor or on a flywheel trigger them. Parallel twins and four-cylinder engines have two pickup coils across from each other, 180 degrees apart. Or the rotor may have two projections on it, which trigger one pickup coil. In a V-twin, the pickups are mounted the same number of degrees apart as the engine cylinders. The VN 1500 has a vacuum line from the intake tract to the igniter unit. The digital advancer in the igniter senses engine load from the vacuum and advances the timing when the load is light for good fuel economy. When the engine is heavily loaded, the system retards the timing to prevent detonation damage. This model has an analog advancer with an engine vacuum sensor. It also varies the ignition timing to match engine load. The ZR1100 has a digital version of this system with a separate controller instead of running the vacuum line directly into the igniter unit. Another use for the computing power of a computerized ignition system was first seen on the KR-1. The Kips valves on this two-stroke twin are controlled by the computer in the igniter unit. Mechanically controlled Kips valves cannot respond exactly to the engine's needs like these computer-controlled valves can. The result is more power and smoother power delivery, both at the same time. Kawasaki's utility vehicle product line uses both a TCBI-type battery coil ignition system and two different solid-state magneto systems. The TCBI system used in the Mule line is digitally advanced and is very similar to the system used on street motorcycles. This system also takes advantage of the digital system's computing power by using it to monitor torque converter belt slip. The igniter unit has a pickup in the speedometer to tell it how fast the vehicle is moving. If the engine turns too fast at very low vehicle speeds, the igniter alerts the driver with a warning buzzer to prevent excessive and rapid belt wear. At the same time, the system also cuts every other spark to the plugs, limiting engine power. The ignition system also governs vehicle top speed. When the top speed is reached, the ignition system cuts one out of every 4 sparks. If the vehicle does not slow down after 1 second, it stops every other spark to both cylinders. After another 0.6 of a second, the system cuts 3 sparks out of 4. While all this is happening, the warning buzzer is sounding to let the operator know why the engine is losing power and to slow down. This system is unique in having 4 projections on the flywheel at 90-degree intervals. This longer projection signals top dead center on number 1 cylinder. The system notes the time it takes for the projections to pass and calculates engine speed from that. The computer in the igniter unit sends a spark to each cylinder at top dead center. The other Mule models use a solid-state magneto system. It is similar to the magneto with points used in the dual-purpose motorcycle mentioned earlier, but it has a solid-state igniter instead of breaker points, and the ignition and pulsar coils are an integral part of the magneto. The tiny solid-state igniter unit senses the voltage rise from the magneto. When the voltage reaches a predetermined point, the igniter opens the circuit to ground, dumping the output through the coil primary winding to fire the plug. The faster the engine runs, the sooner the magneto output reaches the trigger voltage, because the voltage rise curve is steeper. This automatically advances the timing. Kawasaki's portable generators all use the simple solid-state magneto. Most of these systems have no separate advancer circuit, but some do have a feature that shuts off the engine if the oil gets low. A sensor in the sump measures oil level. If the level gets too low, the igniter shuts off the engine and turns on a small warning light on the panel. The light stays lit as long as the engine is slowing down because it uses the magneto's output. When the operator tries to restart the engine, the warning light will alert him to add oil. On the latest generators, the ignition system has an analog advancer circuit built into the igniter unit. These systems are more efficient than the simpler systems in other generators and cheaper to make and repair than the digital system used in the utility vehicle line. This system can also be used to control the low oil level shutoff feature. As we have seen, Kawasaki uses many different ignition systems in different products. Each system best meets the needs of the product it is used in. Some products need only very simple, inexpensive systems. Others need more complex, sophisticated, and expensive systems. For more details and servicing information, see the service manual for the product you are working on and the Kawasaki Ignition Systems Training Manual.